Okay, so today we're talking about translating descriptive form of parabolas and also domain and range. There's a couple ways of thinking about how to translate parabolas, and basically what they mean by translating is that you're shifting your parabola from one spot to another spot on the same graph. So everything on the parabola stays the same in terms of numbers except for the vertex numbers are changing. One way of thinking about it when you are talking about shifting them is if you're just looking mathematically, if you shift up or down, you would add or subtract to the y values because your y values are up and down. If you shift left or right, you were talking about the x values. Now, one thing to remember with the x values is because your values are in the parentheses, it's always the opposite. And so if you're going left, you're adding. If you're going right, you're subtracting. I personally feel like it's easier to see it visually, and so I'm going to show you how to get the correct answer by using a graph. So on example 1, your vertex on this problem, if you notice here, there is nothing with the x. So remember, we can rewrite this, we talked about this last week, as x plus 0 squared plus 6. Okay, that's the same thing as x squared plus 6. So if you look here, our vertex is 0, 6. If you go to graph this, we'd go 0 and then up 6. 1, 2, 3, 4, 5, 6, and make a point. And if we were actually going to graph this, it would be curving up because the a value is positive. It's a positive 1 if it doesn't state it. Now, if you go back and read in here, it says it is shifted down 3 units. So from this point, it's going down 3 units, 1, 2, 3, and making a point. And our parabola is still curving up. So this new vertex right here, this vertex, is at 0, 1, 2, 3. So all we're doing is plugging these values back into this equation. So I have y equals, instead of writing x plus 0, I'm just going to write that again as x squared since it's still a 0, and then plus 3. And that is my new equation once it's been shifted. Now, if you just wanted to do the adding or subtracting, since it's saying shifting down 3 units, the y is just this value on the outside, so we don't have to do the opposite. So you would just subtract 3 here, and 6 minus 3 gives you 3, again giving you the same answer. Okay, so we're going to move on to example 2. As a reminder, if at any time you need to stop the video so people can catch up or whatever, make sure you press enter. Do not press any other buttons except for enter. Okay, enter will pause it and will also restart it. Okay, on example 2, if you notice, the y is not by itself. So the first thing I would do is go ahead and add 3 to both sides. When you do that, we get y equals 2 parentheses x plus 5 squared plus 3. So on this problem, our vertex is -5, 3, because remember, we always take the opposite of what is with the x. Okay, so on our graph now, we're going to go left 5 and up 3. Left 5, up 3, there's my point. Again, my parabola would be curving up because my a value is positive. From there, it says that it shifted left 3 units. So from this point, I'm going to go left 1, 2, 3, and that would be my new vertex curving up. So our new vertex values are at, this was -5, -6, -7, -8, and it's still up 3. So when we write that in this equation, we have y equals 2 parentheses, and it'll be x. Instead of -8, it's always the opposite, so it'd be +8 plus 3. And that is your new equation. Now, if you look, the problem originally started as y minus 3. So oftentimes if it's a multiple choice answer, this 3 will still be on this side with the y. So the answer might also look like this. Y minus 3 equals 2 parentheses x plus 8 squared. Oops, I forgot my squared here. Okay, so either one of these answers is correct. If it was a multiple choice test, you might see it like this as the answer, but if it's fill-in, either way that you wrote these, I would accept that answer. Okay, again, if it's shifting left 3 units, okay, that's dealing with your x and y. So you would do the opposite if you're just doing it over here, and you would add 3. Okay? Because again, with the x, it's always the opposite of what you think. So left 3 would be add 3. And so again, you would get the same equation. Y equals 2 parentheses x plus 8 squared plus 3. Okay, example 3. At this point, I would like you to try pausing the video, but don't press pause. Press enter and let everyone try this one on their own, and then you can press enter again. Okay, so y equals x squared. Remember, this could also be written as y equals x plus 0 squared plus 0, because there's nothing added with the x, and there's also nothing added at the end. So that means my vertex on this one should be 0, 0. Hopefully you guys were able to get that on your own. So on my graph here, I have my point at 0, 0. My curve would be going up because my a is positive. From there, we need to shift 3 units right. So from here, we go right 3 units. 1, 2, 3. There is my point. And again, my curve is still going up. So that new vertex now, 1, 2, 3, is at 3, 0. So when I plug these values into my equation, I'm going to get y equals, and remember the x value is always the opposite, so it's going to be x minus 3 squared. And then you could put plus 0, but you won't see that normally in a problem. You just know it's plus 0 if it's not there. So that is the correct answer. All right, moving on. So example 4, same idea here. I would again though add 3 to both sides just to have my numbers in the correct spots. So I end up with y equals 1/3 times x plus 2 squared plus 3. So looking here, my vertex, remember it's the opposite of what's with the x, so it's going to be -2, 3. So when I go graph that, I'm going to go left 2 and up 1, 2, 3 and make my point. Again, my curve is going up because my a value is positive. From there, it's saying it shifted 4 units down and 3 units to the right. So we're going down 1, 2, 3, 4. 4 units down and 3 units to the right. So then we're going 1, 2, 3. So we have that point there. Again, it's still curving up. So that vertex now, my new vertex, is at 1, -1. So if I plug that into this equation, I get y equals 1/3 parentheses, always the opposite of what's with the x. So that will be x minus 1 squared, and then I still have minus 1. So that is my answer. But again, how it started as y minus 3, it might, if it's multiple choice, be written that same way. So you might need to add 1 back to both sides and get y plus 1 equals 1/3 times x minus 1 squared. So either way, either of these answers is correct. It just depends on how the answer is written. If you're doing it without doing the graph, remember if it's 4 units down, up and down is your y, so that stays the same, so you'd subtract 4 here. 3 units to the right means you are going to subtract 3 because it's the opposite of what's in the parentheses. So again, you'd get y equals 1/3 x, and then 2 and -3 makes a -1 squared, and 3 and -4 makes minus 1. So again, you get the same answer either way. I personally feel just seeing it visually helps me make sure I know I'm doing it correct, because I get confused sometimes with my x's being the opposite and so on. All right, let's go ahead and move on. Now we are going to talk about domain and range here just a little bit. You need to remember that domain is always the x values of the equation, and range is always the y value of the equation. So on these, you're going to graph them. When you're graphing, we want to know, is the graph going to go up or down? So in this case, my graph will be going up because my a is positive. Since it is going up, that means, are we going to have a maximum or a minimum? Okay, we are going to have a minimum. Good, because our point is going to be our minimum point. Everything else will be greater since it's going up. Our vertex on this, it's written in vertex form, opposite of what's with the x, so that will be -2, and our y is -5. With that information, we know that our minimum value is -5. We also know our line of symmetry. It's always the x value of the vertex, and it will be x equals -2. So we're going to go ahead and graph this. We're going to go left 2, down 5, 1, 2, 3, 4, 5, make a point. We know that our graph is going and curving up, and this is our line of symmetry right here. Okay, so we need to know our domain values. Our domain is our x values. Okay, with parabolas, how they are curving here with the x, even though it doesn't look like it, for the domain it's all reals, and it'll be all reals for all your problems because these will keep curving out and out and out and out, and so all x values are included. So for your domain, it will be all reals. For your range, though, it's different, and we talked about how there's a minimum value. Right here, this is your range. It is dealing with your minimum value. Range is dealing with y. So on this one, it's going to be y is greater than or equal to -5. It's always whatever your max or minimum value is, and if it's going up, it's going to be greater than. If it's going down, it's going to be less than. And that's it. So this is your domain and range for this problem. All right, example 2. Okay. So on this one, the first thing we need to know is our graph. On this one, my graph is going down because of my a value being negative. Okay, that also means that I have a maximum value. Our vertex on here is opposite of what's with the 3, so that would be -3, comma, and nothing is being added, so that's 0. My line of symmetry is x equals -3 because it's always the x value of the vertex. And my max value is 0. We talked about how our domain, and if we go ahead and graph this, -3, 0 is right here. My graph was going down. So again, domain is going to be all x values because it'll continue curving out. So our domain is all reals. And our range is going to be y. Since it's going down, it's going to be less than or equal to, and our maximum value is 0. Sorry about that. And also our line of symmetry there goes through the middle. So that is my domain and range. And again, your domain is always going to be all reals. Your range is what's going to change, and depending on whatever your max or min value is, that's your value. If it's less than, it's going down. If it's greater than, it's going up. Okay, last example, example 3. This one is not written in vertex form, so you need to find your vertex, okay? So my a value is -2, b value is 20, and c value is -5. Remember, to find the x value of the vertex, it's x equals -b over 2a. So -b is -20 over 2 times -2. So we get -20 over -4, which makes a +5. In order to find the y value of the vertex, we plug this value back into our original equation and solve for y. So I have y equals -2 times 5 squared plus 20 times 5 minus 5. So here 5 squared is 25. -2 times 25 is -50. Plus 20 times 5 is 100, and then minus 5. -50 plus 100 is +50, and 50 minus 5 is 45. So that's my y value of the vertex. So when we go over here, our graph is going which way? Down. Very good, because our a value was negative, which means if it's going down, there is a maximum value. Our vertex we found is at 5, 45. Since we know our vertex, we know that our line of symmetry is x equals 5, and our maximum value is 45. So if we graph it, we go right 5, 1, 2, 3, 4, 5. And on the y, since it's 45, I'm going to go by 5. So these are like 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, so there's my point. Again, it's going down. And you could always like label this as 5, 45. Okay, so from there, I'm going to go here real quick because I'm running out of time here, but my maximum value is 45. My domain is x is, all reals. and my range is y is greater than or equal to 45. And that is the end.